Assalamualaikum and hi. So now we are going to look at subtopic 4.4 from chapter 4. Force on current carrying conductor in a uniform magnetic field. Alright, there are two learning objectives here. The first one is to explain and use magnetic force equation, and the next one is to determine the direction of force. This subtopic is very similar to subtopic 4.3, where we are going to find the force. As we know, force is a vector quantity. We will have magnitude and also direction. So the magnitude here, using the equation, and the direction here, we are going to use the right hand palm rule. Okay, so what is going to happen here is in subtopic 4.3, we had moving charge in uniform magnetic field, which is going to experience magnetic force. Whereas in this subtopic, we are going to have uniform magnetic field. Let's say we have magnetic field here into the page. And then we have a conductor where the conductor has current flowing in it. Therefore, this conductor carrying current in the magnetic field is going to experience a force here, which is also a magnetic force. Alright. A current carrying conductor in a magnetic field. So this is the current carrying conductor in magnetic field. Experience force given by the force here. Vector force is given by the current, magnitude of the current, multiply with the vector product of the length of the conductor and the magnetic field of the magnetic field. So we have F here is the force, I is the current, L is the length of the conductor, cross product with the magnetic field. Since this is a cross product, the magnitude here becomes I LB sine theta. Okay, current multiply with the length of the conductor, magnetic field, sine theta. Theta here is the angle between I and B, which is the angle between the current and the magnetic field. Usually they are perpendicular to each other. Okay, so this is the equation that we will use to find the magnitude of the magnetic force. Whereas to find the direction, we are going to use the right hand palm rule, where it is very similar to our magnetic force for moving charge particles. Okay, dalam 4.3 kita ada moving charge particles, ada velocity, ada magnetic field. So kita guna right hand palm rule untuk tentukan direction kita punya force will be experienced. Sama juga, we are going to use the same method here. Awak ambil tangan kanan kamu, your four fingers here will be represented by the current. Kalau untuk moving charge particles, fingers adalah velocity. Untuk current in a conductor, four fingers ini menunjukkan direction of the current. Either your current is going up, down, kiri, kanan and what so not. Okay, and then your palm here, tapak tangan ini masih represent the magnetic field. Okay, the fingers represent the current, the palm represent the magnetic field, whereas the direction of the thumb after you swipe your fingers into your palm adalah the direction of magnetic force. Salah tolong betulkan. Adalah the direction of magnetic force. My bad, I'm extremely sorry. It should be the direction of magnetic force here. Okay, so thumb ini indicate the direction of magnetic force. Tolong betulkan. Okay, so cara nak guna right hand palm rule ini sama saja. You make sure you decide the current. Contoh kita ambil example dekat sini. Okay, current ke atas muka surat. So point your four fingers ini ke atas muka surat. And then as you can see, the magnetic field here are cross. So cross adalah into the page. And make sure your palm now, tapak tangan kamu kena point into the page. Flip your hand so that the palm is pointing into the page without changing the direction of current ke atas tadi. And then you can see now your force ataupun your thumb, which is represented by the force, adalah ke kiri. So the force here will be to the left. Ini direction of magnetic force menggunakan right hand palm rule. Kaedah dia sama saja macam kita guna untuk charge particle moving in the uniform magnetic field.